Hello, ladies and gentlemen. This is our last video for the first grading period. We are still going to talk about the last practice exercise, which is concerned on solving radical equations. In the previous two videos, with the same concern, we were able to talk about the basics on how to solve radical equations. Still, we are going to apply those concepts as we solve this remaining five items. But again, a disclaimer, we are going to talk about a radical equations that could actually be solved without even considering the presence yet of quadratic equations. Do not get me wrong. We will talk about quadratic equations soon. So we are not. We may. There are actually instances wherein the radical equations may involve quadratic equations. But since we are just going to focus first on the concern on radical equations, we will go back again to this concern when we will talk about quadratic equations in the second grading. So let me share to you the remaining five items for this last video. Right. So again, we are going to talk about the radical equations for a while. Okay, so I'm looking for the file now. Here it is. Okay. So I have here five remaining items. But as you can see, the difference of practice exercise C to the previous practice exercises is that both sides has are now expressed in radical expressions. So both sides now. Okay. So how are we going to solve this? Similarly, we will use the same process. So let us take item number one. The square root of x plus 2 is equal to the square root of 7. Since both sides are in the form of a square root, we can just simply square them. Okay. There might be a question, sir, what if both sides do not share the same index? So we are going to apply power laws later on. But again, we are going to have those types of more complex examples for radical equations on the situation we're in. We can apply it better. As of the moment, let's just focus on the five items here. So when we take the square of both sides, this would become x plus 2 is equal to 7. And then instead of dealing with radical equations, we are now down to a linear equation. So we have going to subtract both sides by 2. The possible value for the variable x is 5. Let us try to check and to determine whether this is actually a solution. Going back to the given. So you have 5 plus 2 is 7. So this side will become square root of 7 equal to square root of 7 on the other side. This means that this value will make the equation true. Okay, so that's it. We just use the same processes. Let's have number 2. The square root of x minus 4 is equal to the square root of 8. So again, we square both sides and we will have x minus 4 is equal to 8. And then this is now a linear equation. Add both sides by 4. So you have here 12. Okay? 12. So checking, we will use 12 here. So 12 minus 4 is 8. So both sides now are in the form of square root of 8. Okay? In short, this is now a solution. So we'll have your square root of 8 is equal to square root of 8, or if you were going to use the simplify to simply we're going to simplify this radical. This is actually equivalent to 2 square root of 2 equals 2 square root of 2. As to how, you may check the separate video concerned mainly on simplifying radical expressions. Number 3 and number 4. Let's start with number 3 first. In number 3, okay, so in number 3 and number 4, even in number 5, they both sides now have variables. So how do we act on this? So you have 2x, sorry for that, 2x minus 4 is equal to the square root of x plus 3. So again, we simply square both sides. And then you will have here 2x minus 4 is equal to x plus 3. So it doesn't matter if both sides have variables now because we are just down to a um, linear equation. And then you will apply the properties of equality. So you may say 2x minus x, okay, here, so that you can remove the one value here, and you have, uh, so let's start it. Right. We have here 3 plus 4. So you have x is equal to 7. Right? X is equal to 7. Again, we subtracted both sides by x, so we remove the x here. And then we added both sides by 4, so we remove this one, but we added the other side by 4. So the value for x is 7. Let's check it. So we have here 2 times 7 is 14. Minus 4, your left hand side is square root of 10. And the right hand side, 7 plus 3 is square root of 10. Both sides now have the same value. In short, this is also a solution. So since both sides now have variables x, you will substitute the value of x that you have solved in both sides and make sure that both sides will be equal because we are talking about equations. Number 4. The difference with number 4 and to number 3 is that there is a presence of a coefficient 2 outside the given radical expression, the square root of x plus 1. Sorry, x minus 1. Okay. In the previous videos, we were able to identify that we could actually remove this. We could omit 2 by dividing 2 both sides. But by dividing 2 both sides, there is no other coefficient here that can also be divided by this one. So you will be living with a fractional form here. So still, you haven't dismissed the idea of or removed the idea of radical expressions. So instead of dividing to both sides, and again, it works on the other examples. If this side here simply probably 10. And you can divide both sides by 2, just like that. But since both sides are expressed in terms of radical expressions, what you can do here is to still square both sides. And then remember the power law of exponents. We're in, aside from squaring the radical expression here, you also share it to the coefficient here. So this would become 2 squared, not equal here, 4. And then we remove now the radical expression. It's very important to be reminded that this is a group, and that is why we have placed here a parenthesis. Some of you might say, I have 4x plus 5. This is very wrong. Let's use the word very wrong. This is incorrect because you were saying that 2 here is part of the radicand here. Okay, so that is should not be done. Make sure that to group that into one, and then equal to the other side. Since even if you will say there's 1 here, the perfect square of 1 is still 1, so it doesn't matter. You have x minus 1, and then this is your expression. Simply need to apply the distributive property and all the properties of equality later on. So to continue, you have 4x plus 20 is equal to x minus 1. And then you have 4x minus x as you subtract x both sides. And you have negative 1 minus 20 as you subtract 20 both sides. So you have 3x is equal to negative 21. Divide both sides by 3. The value for the variable x is negative 7. Because negative 21 divided by 3 is negative 7. So let's try to check if it's really true. Okay. When we try here, negative 7, right? Okay, let's go back to our solution whether it's there all correct. Okay. When we try here negative 7, let me use the pen. Negative 7 plus 5 is actually negative 2. In short, this side will become 2 square root of negative 2. On the other side, you will have negative 7 minus 1. This will become square root of negative 8. What do you think? Do we have a square root of a negative number? No. In short, this area here do not exist. This area here is also do not exist because there is no square root of a negative number. In short, we check our solution here. Yes, this is the only item that will come out later on. But since this will not make the equation true because it will make both sides undefined or does not exist, this is not a solution. Okay? This is not a solution. Or better yet, there could be no solution for this item here because again, there are no different values for x from this situation here. So this is in number 4, there are no solutions to be found. Let's have try number 5 and let's find out if the number 5 has no solution. So number 5, you have 3x plus 1 is equal to 2. You have x minus 1. So we square both sides because we are under square root. So again, distribute the exponent. You have 9x plus 1 is equal to 4x minus 1. Okay? So we have here 9, sorry, 9x plus 9 is equal to 4x minus 4. And then we try to simplify both sides. So you have 9x minus 4x is equal to negative 4 minus 9. And you have 5x is equal to negative 13. Divide both sides by 5. You will have here as value for x is equal to negative 13 fifths. But what can you note? What have you noticed here is that look at the values. This is more than 1, more than negative 1. I mean, the value of this one is approximately near is in mixed fraction is negative 2 and 3 fifths. But if you're going to substitute any the value for any of the expressions here, they will be similar to number 4. We'll have no solution. In short, for number 5, let's try negative 13 fifths plus 1, wherein this is also 1 can be written as 5 over 5. So negative 13 over 5 plus 5 over 5, we will have negative 8 fifths. Square root of a negative number does not exist. On the other side, we have negative numbers does not exist as well. In short, this is this is also this is not a solution, and you can generate that a value for number 5 does not there are no solutions for number 5 still. But just to make a reference that there are also instances we will have solution, let me try to manipulate this number 5 and let me create here an item. Let's say let's label it as 5.1. Okay, let's try to label it as 5.1. I'm going to interchange the negativities here. So instead of having that, we will have here, let me have, I'm going to change, just for reference, change these signs here. So we'll have 3 square root of x minus 1 instead of plus 1 is equal to 2 square root of x plus 1 instead of minus 1. And let's see if we have a solution now. So we have here uh, the square of both sides. Okay. Square of both sides. And then you have square of 3, which is 9, times x minus 1. And this is 4 times x plus 1. Substitute, you have 9x minus 1 is equal to 4x. Sorry, that's 9x minus 9. Pardon. 4x plus 4. And then you have 9x is equal to minus 4x is equal to 4 plus 9. You have 5x is equal to 13. And then divide both sides by 5. So you have x is equal to 13 fifths. Okay. 13 fifths. So this is not a negative now. This is a positive number. But still, we are not yet sure if this is a solution or not. So to do that, let's do a checking. Just going to illustrate this one. So this we have 3. You have 13 fifths minus 1 must be equal to 2. You have 13 fifths plus 1. This would become 3. Well, we have here a question mark because we're not sure if it's true. And then we have here square root. That's 5 over 5 because that's 1. So you have 8 fifths is equal to 2. This becomes square root of 5 over 5, 18 fifths. Since we cannot, can we? Can we simplify it further? Can we simplify it further? Yes, we can simplify it using the laws of radicals. When you have 3, you have square root of 8 all over 5, square root of 5. Okay. We distribute the exponent, the square root here. And then you have here 2 square root of 18 over square root of 5. Don't worry about rationalizing first. Eh? We are not trying to solve the values. We're just looking if we could actually make the equations equal. Right? So you don't need to rationalize, multiply square root of 5. What I'm saying is the topic of rationalizing denominators. 8 here is actually 2 square root of 2 because that's actually 4 times 2. Right? So that's 4 times 2. This would become 3 square root of 4 times 2 over square root of 5. Right? Is equal to, the other side could also be written as 9 times 2 over square root of 5. And then simplify what can be simplified. You have here that becomes 3 times 2 square root of 2 over square root of 5. Let's place all question marks. We're not sure if they will be really equal. The other side will become will become 2 times 3 square root of 2 over square root of 5. And you multiply. 3 times 2 is 6. You have square root of 2 over square root of 5 is equal to 2 times 3 is 6. Square root of 2 over square root of 5. Again, no need to rationalize. We are just trying to find out if they would be equal. And yes, since they are equal, this means that this is now a solution because it makes the equation true. Right? If you're if you feel like this is more complicated checking, you can just simply go back to this area here. I will give you one more type of checking. Instead of simplifying this 8 here and the 18 on the other side, return this inside. Return that inside. So instead of 3, this will become 9 inside. That should become 8 times 9. And instead of 2, this will become 4 inside. 8 times 9 is 72. 18 times 4 is also 72. That's a better shortcut. So you really have 72 over 5, or the square root of 72 over 5. On the other side, you also have the square root of 72 over 5. That is also another way to check whether our a value of x is a solution or not. What I have told you earlier is the disclaimer that there are also types of radical equations that will yield the concept of quadratic equation and many other forms. that that is what will happen if, say for example, in number, let's say number three, you still have an a value here, let's say plus one outside of the radical expression. You will meet the quadratic equations there. But since we will concern on quadratic equations for the second grading, please observe later on that we will actually go back to an example pertaining to radical equations on the quadratic equations portion, just to make reference lang. Okay, so this is our last video for our first grading period. You may review this video and the rest of the other videos, watch them all over again if you are confused, just for you to be prepared for the upcoming assessment. Please do not get frustrated at one glance, because mathematics is not a to be rushed. It needs a step-by-step process and a patience, part of your discipline. Okay, so thank you very much for watching. We will be providing you with videos again for the second grading topics soon. Thank you very much. Please prepare for your upcoming exam. Goodbye.